Hey, what is up guys? My name is Deshono and welcome to episode 34 of 3D Game Programming in Java. Oh, it feels so good to say that because I haven't said that in over a month. Okay, so we're back. Hope you guys have been enjoying the morning coffee series, by the way, because that is taking a ridiculous amount of time to make. I don't know how I'm going to be able to keep it daily, but I'm going to try my best, especially over this next week, to try and get an episode out every day. So you guys should see an episode out every day except for Sunday, because Sunday is 3D Game Programming in Java Day. Or actually, I've sort of renamed it to 3D Game Programming Day. Alright, so today, I've decided to do a few things today. Today, I wanna spend it more on I wanna sort of orient this series more towards actually talking about what I'm doing than getting a bunch of code down. And the thing is, it's really hard to do that because when you're making a 3D game, there's a lot of processes. You have both in your mind while you're doing it, and also, you know, in terms of code. So it's kind of hard to try and make a bunch of 20-minute, 30-minute, whatever, 50-minute, 1 hour long episodes where I write, I don't know, maybe about 100 lines of code each, because at that rate, it would take a few years to make a 3D game like this. Not even like this though, because this is I might talk a bit about this kind of 3D game because you guys might have realized, this isn't exactly this isn't really a 3D game, right? This is just it's essentially a 2D game with a 3D looking perspective because technically, if you check out, the definition of 3D in computer graphics, this is not really it, because this is just a raycasting engine, right? So there's a few things. There's ray tracing. Don't get it confused with ray tracing. Ray tracing is a more of a 3D rendering technique that is kind of slow, so it's not really used in games. But raycasting is the name of this engine. And I don't know. I guess I should probably explain that earlier. But this is sort of orientated at beginners, I guess, and a beginner's going to be like, oh, cool, raycasting engine. Yeah, great. Now I know what it's called, but I don't know anything about it. But yeah, so this is the same type of engine that was used for dungeon crawlers, I guess, like Wolfenstein 3D and also Doom, the first Doom game. It's pretty much this engine. So yeah, I've sort of expanded it a bit by making the ceiling 2 blocks high instead of 1. I just thought that I'd play around with that for for experimental purposes. This time is really dodgy, actually. I want to do a few things today. The main thing I want to do today is entities, though. You might have seen it by the title. So as I said, I want to start taking it slow. I want to start. I guess my year 12, my final exams for school are going to come up in November, and I'll probably spend the entire October. October's before November, right? Yep. Yes. So I'll probably spend the entire October studying for them because these are my final exams. Basically, my future will depend on what mark I get in those exams. As well as throughout this year, but about 60 to 70% of the mark is going to come from those exams. So it's very important for me to do that, which is why I do want to take it slow. I don't want to get into too much. We've basically done, I guess you'd call it boilerplate code. And boilerplate code is just it's code that basically gets repeated for whatever the hell game you're making, or whatever application you're making. So something like setting up width and height, setting up a screen class, or in this case a render class. Setting up the timer. Yeah. I think I might redo the timer actually. I don't know if I'll do that right now. I don't like the way that it's currently handled. So yeah. Okay, well, we're going to do entities today, but I guess as a little bonus, I'm going to redo the timer first. So let's get rid of ticked. A lot of you guys have been complaining that I've been using ticked. Tick is essentially update, right? So we could rename it to update. It's the same thing. It's a bit of a convention to use tick in game programming. It's I don't know. You'll see it a lot. So be mindful. Tick is the same as update, right? I write both ways. I've actually sort of leaned into running update more now, but yeah, so let's order this. Tick count is basically updates, so let's just make a new integer. We'll call it updates, and we'll set it equal to 0. Alright? And instead of having a boolean for this, let's get rid of this. Let's render. We should be rendering as fast as we can. So let's actually, okay, so the purpose of this code, obviously, is to basically say that, yeah, whatever's here, let's have it happen 60 times, right? And I didn't say that right. I meant let's have that, let's, I guess, module it to 60. So in other words, once every 60 ticks, we're going to do whatever's in here. Once every 60 updates, which essentially results into a second, because we're supposed to be updating the game at 60 times a second, right? There's a big difference between frames and updates. A huge difference, because you want to always, you want to basically keep the updates static, and not Java static, not Java static. You want to keep the updates static, as in, you know, that they don't change. So I guess to illustrate this in a different point of view, excuse me for my voice as well. I'm a bit sick right now. It's winter in Australia and it's cold. Anyway, yeah. So to illustrate this in a different way, think of this, right? My computer right now is it's still considered faster than the average computer, even though it's 2.5 years old. Because I built it 2.5 years ago. But it's a very fast computer, right? You might be sitting on a laptop. The difference is I might be able to, you know, I guess render this game. Let's not talk about this game. This game's a bad example because it's not very efficient. But and I might spend an episode making it more efficient, but we'll see about that. I don't think there's a huge need to be honest. You might be running a 2D game, say I might be running a 2D game at 500 frames per second, right? But because your computer's not as good, you might be running it at 100 frames per second. Now, the problem with that is that if we ignore updates and just say that, oh, okay, the FPS is going to be the same as the updates, then essentially my game is going to change its state. It's going to update 500 times a second, and yours is going to do it at 100 times a second. Now, the obvious problem there is my game will simply run faster. It'll actually physically, everything will move faster because the computer's updating, you know, I guess updating the positions of AI characters, updating the player's position 500 times a second, whereas yours is only doing it 100 times a second. So in 1 second, you know, if I'm moving 1 pixel or whatever, 1 unit once every cycle, then I'm moving 100 units per second. You're moving, I'm moving 500 units per second. You're moving 100 units per second. So in other words, the purpose of this timer is to make sure that we stick, and by convention, it's 60 frames per second. Now, why 60 frames? And by frames, I mean updates. I'm actually confusing you guys, aren't I? VSync, for example, limits your frame rate to 60 per second because you know that'll basically avoid you know, updating too much. But it's not a problem with this because we're not running too fast. If we were running above 500 FPS, I'd probably enforce something like 60 FPS or make the thread sleep for 2 milliseconds or something every now and then. But the point of having a timer like this is so that we can update the game state. We can update the logic of the game at a set amount per second. So if your computer's very fast and my computer's very slow, or vice versa, or whatever, then, you know, our game will look exactly the same. Okay, that's the case. So by convention, and this isn't really by convention, because if we go to, let me just duck down screen resolution here. If we go to advanced settings, you'll see that the refresh rate is, mine's actually at 59 Hertz, probably should be at 60, but a 60 Hertz monitor, I'm not gonna apply it right now just in case it screws up my screen recording. It should be 60 though. It's pretty popular. That means that we can basically we can see 60 frames per second. So our monitor will update 60 times a second, right? There are a bunch of 120 Hertz monitors, which apparently are really smooth. You would be able to, you know, in case of that, I'd probably make that like 120 or so. But because our monitor is not capable of, I guess, updating more than 60 times a second, you know, you might as well limit the frame rate to 60. But I I guess it's fun to see how fast, how efficient your engine is, so people don't really do that much. But anyway, by convention and by point, it's good to limit your updates per second to 60 FPS. Leave that usually unlimited. Again, if you're running, if I'm not gonna go into the whole, I don't know if you guys like this new format that I'm trying out, where I just spend time explaining stuff like this, but I think you will. This is kind of turning into more of a podcast, and I should probably stop. Okay, so let's just wipe out this code. Don't need that, don't need that, don't need this, and don't need this. And current time, past time. Okay. So, we're dealing with NanoTime here, which is nice, but on the other hand, it means that we have to convert nanoseconds to milliseconds for the purpose of a timer. So 1, 2, 3, 4, 5, 6, 7, 8, 9, which is 1 billion. And we want to divide that by 60. Alright? Because we want our FPS to be limited by... We want our updates to be limited at 60. If we wanted our updates at 120, we'd put that to 120. And this 0.0 at the end, a few of you might be wondering why you need 0.0 and why not just this. One of the reasons is that if we put a 0.0, we're basically telling Java to handle this as a double, else we're just telling it to handle it as an integer, which means that 1 billion divided by 60, you know, I don't know what that equals, but I can find out. That's gonna be this. If we divided it, if we don't have the 0.0 here like we do now, it's not gonna give you that. It's gonna cut this off, and because Java rounds down, I'm pretty sure, it's gonna give you that number without this precision, and we do want the precision because we want it to be as precise as possible. Hence we need to put the 0.0 at the end. All right, anything else we need? Probably delta. We'll set that equal to 0. Okay. So essentially, let's push up request focus into here. Whoa, is it really in there? Shouldn't have been in the running loop. Okay, so what we want to do is, we got the current time. What we want to do now is we want to add to delta the difference between the current time and the last time, the previous time. I think that's right, yeah? Yeah. And then we want to divide it by nanoseconds. So divided by our nanoseconds. Conversion into milliseconds. Okay, and we want to set current time. Rather, we want to set previous time equal to current time. Okay, so now we want to say that if delta is greater than or equal to 1, which should happen 60 times a second, let's just first of all subtract from delta, and then let's increase our updates, and let's tick. Okay, there we go. And in between that, we should render. So let's grab render in frames. That should be here. And then while system.current time milliseconds minus previous time is greater than 1000, which will be once a second, we want to do all this stuff. So yeah, and we also want to make sure that updates equals 0, so that we reset that. Okay, we haven't used this. It's alright. It's the same as delta. Unprocessed seconds is identical to delta. Okay. Yeah, okay, so that's the new timer. That should work. Let's just run it. And we'll see what we get. Alright. Well, we're chilling at 0 frames per second right now, but our game is running smoothly, and it's not updating that, so something is wrong. Oh, whoops, my bad. Okay, previous time. Let's make a long haul timer. We'll set that equal to system.current time milliseconds, and we'll make sure that we're doing this, and we need to add 1 second to timer. just like that. So let's see if this worked. Yeah, okay, it did. So now it's telling us that we're running at 40 FPS, which is pretty accurate actually. I think we are running at 40 FPS, which isn't good. Let's... I'm not doing anything to updates either. So, updates plus... Oops. Updates, or UPS, updates per second, plus frames. Okay, so they should be identical in this case, which they are. Okay, so this is always going to try to be 60. It's a bad example because so let's just lower the resolution, just for the purpose of this, to 80 by 60. That's tiny. Oh, we've got the whole configuration thing going on, don't we? So long since we made this. 80 by 60. Wait, I didn't even finish this, did I? Okay, let's play. Okay, so you can see that we're running at 60 frames per second, and it's actually doing it twice. I don't know why, but you can see that we're running at 60 updates per second, so that's limited to 60. However, our FPS is much higher. So yeah, there's no point to this existing, is there? Let's just make sure that we're at 800 by 600. Okay. So, excuse me. Okay, we're back. Why is it doing that twice? Did I? No clue. I don't know what's going on. Yeah, that's fine. It seems to work. Okay, so now let's move on to the main aspect of this episode. It's 17 minutes in. I'll give you guys a nice, chilled, relaxed, long episode, because there hasn't been one for like a month or so. Actually, when was the last episode of 3D game programming in Java? Let's see. June 10th. Wow, really? It's been like 2 months. Yeah, it's been... Wow, it's been like 2 months since the last episode. I'm sorry about that. Okay. Huh. Oh, yeah, I privated the live stream, by the way, from yesterday because it's completely screwed up. But this guy just sent me a comment saying that he's still watching it. Oh, and he's got the troll face as well. No, I'm gonna have to show this. It's kind of funny. Hang on. So this wise guy over here is still watching the live stream, and he's got a little troll face. So yeah, it's pretty accurate. Anyway, let's get back into this. So, entities. Yeah, that's right. Okay. So at the moment, I hate this view. I hate this little view. The package explorer seems to show like all the folders not as subfolders. So in other words, this should be a subfolder of this, but it's not. It's just showing all of them. There's another perspective called navigator, which shows you everything in folders like it should be. So like this. And I just find it a lot easier to navigate. So let's go into, we don't even have, yeah, sure, okay. Let's make a new file, or class rather. We could make a new file, it doesn't actually matter. Call it entity.java. Just gives you a nice clean, I don't usually make them as files because there's no point. So mine front, and let's put it into entity. So let's make a new folder called entity. That's not spelled right, is it? Rename and oh, it is spelled right. Damn, I'm paranoid today. Move it into there. Okay, sweet. So now we've got an entity class. Now, a lot of people are always confused by the aspect of I guess, subclasses, or in other words, classes that extend other classes. And I think that a good way to explain it is that it's a template, right? So we've got an entity class that we've made right here, right? It will never be instantiated, okay? It will never. In fact, we should probably make a construct. It would be good programming practice to make a private constructor just like that, because that would just ensure that if we were to try and make, entity E equals new entity, then it's not going to let us because because it's not visible. So that would be good programming practice. Let's just get rid of that import. And it's gone. Control-Shift-O organizes your inputs, by the way. So yeah, I guess that's a good way to do that. Quick, simple way to make sure that we never actually instantiate entity. Again, with the morning coffee episode 1 on visibility modifiers, it's more useful to use visibility modifiers like that if you're working in a group or in like a company or whatever, and you're like, you're constantly like sharing your code with each other. You're constantly sending, the other guy your code and being like, okay, do this for me. Or you've got to hang on. I'm noticing a pattern here. This always stays at 22, 22, 22, 22. I think that there's I'm not gonna spend my time doing that now though. Actually, getting distracted. Anyway. So I guess that's more in a thing, but if you send someone your code and they're like, okay, how is he structured the entity class? When he sees this, he'll be like, oh, alright, well, there's no way that this guy wants me to actually make a new entity, okay? If I need to make a new entity, I'm not going to use the entity class to do that. I'm going to use a subclass of entity to do that. So yeah, I guess think of this as a template, right? So what do you want to do? You want to, in fact, you could call this protected actually as well. But I'm just going to call it private until I need to call it protected, if I need to call it protected. But again, template. Okay, what do I need to have in the entity class, right? Every entity that I make, whether it be the player, a mob, other players, if it's multiplayer, whatever, they all have a how do I call this? I guess a set of properties that is applicable to every single entity in the game. Right? And those properties, instead of having to copy and paste them for every single entity, I can just make like a template, or like, or in a superclass in this case, but I could just make like a reference of those variables, so that whenever I make new entities, whether it be, the player or whatever, they're gonna have these variables already assigned to them. So, let's make a few protected variables. So x and y first of all. They're going to be the x and y location on the map. I'm going to call it x and z just because y is vertical, so I don't really want to mess with that. What other things do we need? I'm just doing this on the fly, by the way. I don't even have any notes in front of me, so I might be coming back to this class and adding more of this stuff because I don't know what I'm doing. Okay. What else do we need? I like to have a protected boolean called removed. So in other words, if we run the public method, the public method, public void remove, then it will set removed equal to true. And basically, what this will do is when we talk about array lists in the future, we can be able to see that if removed equals true, then remove the entity from the array list. So in other words, destroy it, stop updating it, and stop rendering it. And you will see that in the future. Okay, that's going to be it for now, because I can't think of anything else. I don't want to put Sprite into here. How are we even managing sprites? I'm sorry, by the way, it's been 2 months since I've opened up this project, so I have no idea what the structure is. I've forgotten everything. So yeah, just bear with me through that. But we're just handling a single sprite sheet, aren't we? And okay. And we're setting. Hang on. Aha. Okay, we're statically setting. Oh, why are we doing it that way? Yeah, I probably wouldn't do that now. If I was to rewrite this game, I'd probably do it completely differently. To be honest, I'm not sure why. Yeah, that works too, I guess. Anyway, so let's make a few more things. Let's just make a mob class. So let's create a class, make a new package for it, and we'll call it mob. And mob will extend entity. Okay, so let's import entity. Make sure you import the the myFront one, not the Java X whatever the hell was there. Yeah, we're gonna have to have a constructor for this. Let's just call this protected, so that we get rid of that error. Okay. Let's see. Okay, so a mob is gonna basically, because we're extending entity, right? X and Y and removed are already in here, so that's all fine. But you know, basically now we're saying, what do we want all mobs to have in common that all entities don't? So in other words, if we have like I don't know, a rock, we don't want the rock to be able to move exactly, do we? But we do want entities to be able to move. So what we need is a move method, right? A move method. So the amount is going to move in X, and the amount is going to move in Y. And this method is going to basically move the player, or whatever. In fact, let's just make a player class. At the moment, we've called a controller, I believe. Yeah, okay, let's just move the controller class to mob. And let's change the package declaration. And let's rename this. So control, what am I playing? Alt-Shift-R to refactor it, so that we don't need to copy and paste the name. That's alright. And import our stuff. Okay, let's just check that it still works. And we've got an error somewhere. Oh crap, we've got a lot of errors. What's the problem with this? Oh, it's in a different package. Damn, this is gonna take a while. Oh, maybe not. 7 errors. 0 errors, yay, okay. Let's check that we can still move. Yeah, okay, we can. Okay, so at the moment we're using an interesting way to move. Let's just make sure that player extends mob. And now what we want to do is we want to fix up a bunch of this stuff. So first thing we don't need is these two variables. And also I don't want to be able to immediately okay, so Z isn't public. Let's make this public. Okay. I don't want to be able to I don't want to manipulate, I guess, the X values immediately, but rather I want to I want to call a move method and I guess modify them separately. So you'll see what I mean in a second. So what I want to do is in here, first of all, okay, a few things that cross my mind when I think of. Now this is interesting. Look at this. 43 updates. 43. Oh no, don't worry. I swear I saw something different there. Anyway. First thing that crosses my mind when I think of this is collision detection. Immediately crosses my mind when I think of moving, and the reason is that if we handle collision detection in a fairly efficient way, it will completely crash if we try and slide against a wall. So in other words, when we crash into a wall, we don't want to, you know, move backwards being the only option. We sort of want to be able to slide across it. This is sort of more applicable for 2D games, but I think it'll work for 3D as well. And basically what we want to do is say that if we're and the way we can fix this is if we're moving. So in other words, if 0, okay, this is either going to be -1 or +1, right? And in fact it's going to be everything in between because this is 3D, but the point is 0 means that we're not moving at all. So in other words, if both of them are not 0, so in other words, let's just make sure everything's called Z. So if we're moving in both directions, if we've got like W and D pressed down, if we're moving both left and forward, then let's handle them individually by just moving this, and then just moving that, and then make sure we return. So what that's going to do is it's going to return out of the method, and then it's going to process it twice, but in a much better way. So basically what we want to do is just x plus equals xa and z plus equals za. Okay? And we'll have to figure out rotation and everything in a second again. So let's get rid of this. Okay, so if we move forward, we want to xa equals 0 and za equals 0. So every time we go through this tick method, this update method, we're going to set them back to 0 again. So if we move forward, we want za to be plus plus. So in other words, za will become 1. And remember, it won't become anything greater than 1 because it will be reset to 0 before it does it again. So if we go back, we want to minus minus. We might have to flip this control as well. I'm just doing this on the fly again. xa plus minus minus. And right will be xa plus plus. Okay, so rotation left and right. That's cool. But yeah, this could be a problem actually. Let's hope it's not going to be though. So after rotation, yeah, that's actually really interesting because I don't know how this is going to pan out. Okay, let's just see how this works. Let's just move like that, and we will actually need to know the rotation value. Keep writing YA instead of ZA. Let's get rid of this. That's just the mouse stuff. So let's go into move, and let's make sure that we rot for rotation. Okay, so what we need to do basically is set, I guess, a new x. I call them nx, and basically we need to use vectors here to make sure that we just a bit of water. We need to use vectors here to make sure that we're going the right way. So I want to bust open paint.net so that I can show you guys what I mean. Okay, so if we're going this way, for example, we're not going straight or whatever. We're going at that angle. And this angle, let's just say it's 40 degrees. That is crap. I shouldn't even try. I should just use this, shouldn't I? 40 degrees. Essentially, what we want to do is we want to figure out how much we need to move up and how much we need to move right. So if we're facing this direction, we need to figure out the up value and the right value that we need to move. So the up value will technically be z because this is 3D, and this will be x. We need to figure out the z and the x value, the amount of the z and the x value that we need to move every update, basically. So in other words, this might be something like 0.8. This might be something like, I don't know, 1.0, because obviously we're going. Actually, technically, if it's 40 degrees, it'd be the other way around. But my point is, well, what's this supposed to be? Is this really me writing 0.8? Holy crap. Anyway, I should just use like a tablet or something. One of those graphics tablets, the drawing things with a pen. Anyway, so to work this out, what we need to do is use a very complex algorithm that we've already used before to figure out this. So in other words, what I'm going to do is we need to x plus equals nx. So nx being, this value or this value, depending. That's for z though. So we need to add it to that. Okay. So double nx is going to equal something to do with rotation. So let's okay, hang on. Nx is going to be cosine, because cosine is to do with x and sine is to do with y of the rotation. Except we'll need to figure something out here as well, because that'll probably be too fast. Let's just do the same thing for, whoops, for y. Okay. Now we're also going to have to multiply this by, let's call this z, by za. So in other words, if za equals 0, it's going to give you 0, and the z is not going to move at all, which is actually kind of wrong. But we'll figure something out in a second, because the other thing is we need to add. Oh, sorry, this should be sine. We need to add oops. We need to add this to the equation and subtract it from this. I think that's right. Okay? So that should give us the right thing, and then we can multiply by whatever modifier we want if it's going too slow or fast. Let's make these double. Hope that nothing crashes. Good. Yeah, it's gonna really be interesting if it works. Okay, so let's get rid of this. Yeah, so you can see that basically it's the same code that I just wrote. Except I think I did it wrong. Because, where are we, mob? Because this should be sine, and this should be cosine. Is that right? I guess we'll see. Yeah, okay. Okay, let's check it out. Okay, so it works. And not exactly. So you can see how that does not exactly work for rotation. But main movement does work, and we are very fast, so we might slow that down. Okay. So now let's figure out the problem with this. I feel so weird doing a tutorial, by the way, because I haven't done one in 2 months. So just give me a break, just for this episode. So something's wrong. Something's not adding up with the rotation. I'm not sure what it was. Probably shouldn't have been so quick to delete. Maybe for rotation A? No, definitely not. Thing that's bugging me is that it is sort of working, isn't it? Forward 45 degrees, like, say it's not completely stupid. Although I can't get it to move that way. Yeah, that's odd. Okay. Let's come back here and see if we can. Maybe I was right in the first place. Nope. Clearly not. Okay. Huh. Make sure that everything's right here. And exit. Whoops. What did I just type in? Placeholder. I want to see the render 3D class. Make sure everything's right here, and that does in fact go to. Oh yeah. Let's see how rotation's set. I screwed everything up, I think. Huh. Okay. Let's deconstruct this and make sure that we're doing everything right. First of all, we want rotation to plus equal rotation A, that's for sure. So that when we rotate, oh. Yeah, maybe not. That makes it nice and smooth. Okay. So it's working, I think, until 90 degrees. Yeah, okay. Let's figure this out. Let's go into the move method. And let's check out what the value of rotation is right now. So it's 25, it's 26. Oh. That's weird. Yeah, it's clearly not working. Because, oh, okay, that's a bit of a problem, isn't it? Huh. So we just keep turning, basically. I think it's in radians, though. It should be in radians, shouldn't it? The whole thing should be in radians, not degrees. So 1.5. This should be 1.5. This should be 0.5. Hang on. If it's in radians, so it's 3 radians for. Oh, that doesn't work either, does it? But it's 3 radians for for a half a circle. That's wrong. That can't be right. It's supposed to be. Oh no, that's right. That is right. It is in radians, and it is right. Because pi is 3.14, and that's what this is, basically. 3.16. Okay, that is right. That's good. So it is giving us the correct rotation value, that's for sure. But oh, first of all, it's moving us every second. Let's make sure that it only moves us if xa doesn't equal 0, or make sure you don't put and, or za doesn't equal 0. Let's actually let's quickly go into window preferences. Let's go into Java, I think. Yeah, Java code style formatter. Edit this, and go into control statements and keep simple if on one line, so that when we hit Control Shift F, it formats it nicely like that, because it is just a simple if statement with just one line. So we might as well keep it like that. Okay, so now we shouldn't be yet. Now we should only update, as you can see, when we move. Okay, so then something's wrong with this math then. Let's not print the thing because we know how it works. So xa times equals, so in other words 1 times equals that plus, how is this wrong? I don't get it. This is negative, right? That's not gonna work. Nope. Ah, this is boggling my mind right now, because I don't know what I've done wrong. Hang on a minute. Why is this code here? It's interfering with. Oh my god. Did you just say that? Oh god. I'm gonna cut the last bit of me. Yeah, this is stupid. See, this is what I'm talking about. This is why you should add comments into your code. That just cost me like 20 minutes. Okay, now it's freaking works beautifully like it should have from the very beginning. Just get rid of this crap. Unbelievable. Yeah, so the reason that didn't work, if you didn't see it very clearly, now we're freaking sweet. Rotation speed's a bit fast. But apart from that, it's a bit slow. 0.3 might be nice. Oops. Okay. Let's just leave it as let's just leave it at that. All right. So, you might have noticed that the problem there was that we were also adding an incorrect value to the thing. We were also doing this as well, which was interfering with everything because it was causing this to happen. Or in other words, you basically just ruined everything. So, and I didn't realize that code was there because I'd forgotten how I'd made moving work in this game. So that sucks. All right. So now we've got entities, right? We've got our entities working out correctly. We've got a move method for our lovely mobs, and we've also got a base entity method which contains a few different values. What I want to do now quickly before I go is set up a few things in level. Okay, so at the moment level has an array of blocks which add this stuff, right? But what I want also to happen is public void render, or more like update. So I want this code right here. That's the constructor, isn't it? Huge. Let's quickly get this crap out of the way. Generate level. Plop that into there. Okay, update. Let's basically what we want to do is we want to update our entities. So in the beginning of this whole thing in our display class, we've got a player. Where's our player variable? Now again, I could be wrong because I haven't actually. Don't remember how this works. Oh, it's in our game class, isn't it? Yeah, so we basically got this going on here. So we're updating the player, we're updating everything throughout here, which is cool. But we want to be able to update if we have like 100 players in the game or whatever, 100 mobs in the game just running around. We don't want to have to create new instances of each of them. We don't want to have to say, alright, let's make another player called player 2. And now what we're going to have to do is we're going to actually have to create the new player. And we're going to have to also, tick the new player, right? And you can imagine that if we've got like 1,000 of them or whatever, then we'll have this huge thing here that is just crap and we don't need. So the solution to that is to use an array list. Now, what is an array list? We've never used an array list before in this series. And a bunch of you are probably wondering what an array list is. And I will answer that in a minute. Maybe I should save it for next episode, actually. Nah, we'll do it this episode. Okay. So, an array list is basically like an array. Hence the name, right? So, what we could do, you guys might say, is let's just make an array list of players, right? Called players. And then what we'll do is we'll add as many as we need to that. Now that's cool, but what if we want a specific, what if the amount of players changes, right? Once the player is dead, once we kill another mob on our screen, we want to remove it from that array to save memory usage. We want to get it out there because we don't want to be updating it. We don't want to be rendering it. It's gone. It's dead. Let's get rid of it. Let's call the removed method and remove it from the array. Now you can't do that with entity. You can't do that with an array. Okay. Because it's not dynamic. The size of the array, the index of all the items in the array, that's fixed. Once you set that, it's done. What we need to do, so like with blocks, right? We can't change which block is where while we're running the game because it's an array and we've set it up once. Now an array list is like a dynamic array. Okay, there's no such thing as array index out of bounds, because the bounds of the array are whatever as much as we need, basically. If we can keep adding, I don't know, 1,000,000 mobs to the map, and it'll still be fine. So apart from, you know, all the other crap like memory usage, and mostly memory usage actually, and probably processing time as well. So what we want to do here is we want to set up a new array list which will hold all our entities. So right, all we need to do is go private list entity. Now, first thing you're gonna ask is, what are these fancy less than and greater than signs enclosing the word entity? Now, this is basically, all this is doing is it's saying that this list is going to contain a type of object. It's going to contain entity objects, and that's it. We can't add, for example, a level object to this, right? We can't just decide to add a level to it, okay? It needs to be, if we set entity as basically the contents of this list, it can only contain entities. This list can only contain entities. We'll call it entities, since I've been saying that word for the past hour. And it's the name of the episode. And we'll set that equal to new array list, and again, entity, right? And then you'll have your things as usual. Now let's import it. So, make sure you import the one that is in a util, not not AWT, util. And obviously, the entity is our entity, and that's it. Okay, sweet. So now we've got an array list. Now we've got an array list of entities. What we want to do now is public void add entity and entity e. So in other words, we want a method to add a new entity into the level. So all we need to do here is say that entities dot add e, right? So it's going to add whatever entities in the parameters to our little list. Now, we need to update every single entity. Now, the reason I'm not making a render method is because we're not actually rendering the player. The player's like just a camera. It's not actually being rendered at the moment. We'll probably get onto that later. But anyway, so in other words, for int I equals 0, we need to make a for loop to render all of the entities in the list. I is less than entities dot size. It's not length. In arrays, it's length. In list, it's size. It's sorry. Let me just grab some water. In lists, it's size, and it's also a method. It's got these things, I++. And all we want to do is we want to entities dot get. Now the index is going to be I, right? And we want to update. So tick or whatever. Now, okay, so to do that, we need to make the actual update method. Okay, so yeah, okay, so you can see that I've made like a method here that doesn't do anything. That's cool, but remember, if we have the exact same method in player, it will do something, because we're rendering we're actually doing a player thing. We'll see in a minute what I mean. Tick. Let's come into player and get rid of this crap. Let's just rewrite the entire tick method. So, come with me, cut. Oops, don't want the last line. Oh, there we go. Paste. Okay, so a bunch of errors. That's no problem. Public player. And, input handler, input. And we'll make a private input handler here called input. And we'll just set this dot input equals input. So all we're doing is we're saying that when we create the player initially, we'll put an instance of the input handler object there, and then we'll just set this input equal to this input so that we can use the input handler objects throughout this class. So let's go into the input handler thing, and oh, there's a lot of crap here. Let's make a bunch of... Yeah, okay. Let's make a bunch of, go into game and just grab this. And pop it into here. And we need to make an update or a tick method. And we just need to basically set this. Okay, let's cut this and put it here. And then boolean forward, back, left, right, rotate, left, rotate right, jump, crouch, and run. Okay, and let's come into here, and I'm pretty sure that we've got yeah, we do. In game.tick, just under game.tick, input.tick. And we don't need this. Let's get back into our display class real quick. And game class, let's move this up. Whoa, whole screen just flashed, it's odd. Where's game class? Where's my game class? Okay. So, new player, and it'll be input. And looks like we'll have to add this into here. And over here, we'll just add input. And make sure that it is, that this thing is before it, otherwise we'll get a null pointer exception. So we'll set input equal to that, and then straight away we'll just add it into the game. Get rid of that. Cool. So, a few errors. That's alright, we're fixing everything. Okay, sweet. What's run? What did run used to be? I've got no clue. Make it public. Run. That's shift, isn't it? Yeah, it would be. Okay, so we fixed everything up. Let's see if it works. And it works perfectly. Okay, sweet. So now we've got this in here. Now, this is going to be the longest episode ever, isn't it? No, well, I am going to cut like 20 minutes out of it, so maybe it won't be. Okay. Oh, I gotta get back to watching Dexter. It's like 4:15. I just finished season 1 of Dexter yesterday for the first time. Oh, it's so good. So good. If you haven't checked out Dexter, check it out. It's actually such a good show. Anyway, let me just turn the backlight on for my keyboard because I can't see the keys. And I like seeing the keys because it's cool. And I can actually see what I'm doing. Okay. So what we want to do is we want to level.add player. Okay? So that way we don't need to tick the player. We only need to tick the level. Did I call it update? Yeah, I did. Not really consistent, but it doesn't matter. Level.update. Let's call everything tick. Rename. Call everything tick for this project. That should work. So let's just see. Crashed. Why did it crash with a null pointer exception? So level equals null. Yeah, see. You want to do that after you set level equal to. No, not Java EE. No. Okay. So this should work. Yeah, it does. Okay, so you can see that we're updating the player perfectly right now. Even though we're not actually technically calling the update method of the player. So in other words, that is mission accomplished. And yeah, so let's make the map a lot smaller. And next week, on Sunday, we could do one of two things, guys. So I'm gonna have to actually get you to post. Oh, so many walls. Let's make walls a bit rarer right now. So let's just say 28, and maybe this 25. There we go. Nice. Okay, so two possibilities for episode 35. We could either do collision detection, and I know a lot of you guys are gonna like jump up off your seats and be like, "Oh, finally!" Yeah, so we could either do collision detection next Sunday, or level design. And by level design, what I mean is that we're going to be able to go into a program like Paint.net and basically, you know, draw whatever level we want, and each separate color will be a different type of block. Okay, so we could do that. So either level design, where we'll read the level file as being an image, as a PNG image, and each different color is going to be a different block at that particular location. So we can basically draw a top-facing map of the level, and that will actually be what the level looks like. Or we could do collision detection. One of the two options. Okay. So I'm thinking about this right now, and I'm like, I don't know what's gonna win. I know you guys want collision detection, but you also want level design. So that we'll do next week, guaranteed, one of the two. Unless something very bad happens and I won't have time or something. So yeah, thanks for watching this episode of 3D Game Programming in Java. Give it a like because it's very long, and because there hasn't been an episode in so long. So yeah, and I'll see you guys next week. Bye.